From problem to pseudocode, how to plan your robotics programs. The first thing to do is to identify the problem. What has your robot been tasked to do? As an assignment, you have been given the task for your robot. Once you read through the task, you need to analyze it and determine exactly what this task will entail in order that you can best develop, design, and eventually implement a program for your robot. You'll also notice right here in this task, the instructions include be sure to plan your action. So we want to have a plan. Creating a plan, we have to be careful not to be too simple. For example, if we have read the task, then we know that the robot's supposed to go to an object, pick up the object, and come back. And if our plan says send the robot to the object, get the object, and return, restate the problem. Not that it's a bad idea to restate the problem, but it's not really a plan that's going to get us through to code. We also want to be careful not to get too complex. Here we have our three main ideas, but then we start thinking about all the other things, and we start piling it all onto the same piece of paper, and eventually we get all these ideas, but we've jammed them all in. And so we want to take a little time and kind of go back to the original idea, what the actual task is, and look at how it breaks down. So we know that we have our robot, which we've already designed, and we're going to send that robot forward to the object. Once that's done, the object will be returned with the robot. And as we're developing our plan and we're thinking through these steps, we want to use relevant language like moving forward and grabbing the object with the claw. Or if we want to talk about reverse or any directions that we're going to be going, we want to try to get those through at this point. So our breakdown has drive robot forward to the object, pick up the object with the claw, return the object to the starting point. It's a little bit more detailed than the 3 points that were in the original task, but it's not overly detailed. We're going to get to the high details next. So let's break it down further. Drive robot forward to the object. We could say drive forward until the object is detected. This is an important distinction that we want to make sure we include. So how will we detect the object is important. Here I've suggested with a bump, some sort of bumper sensor. But we want to make sure we're not just driving forward blindly. And this is an opportunity to indicate that, which will relate directly to our code. And then we had step 2 said pick up the object with the claw. Well, to get a little more detail, we can say close the claw on the object and lift, so that we have our robot coming forward and then it picks up the object. Step 3, turn the robot around 180 degrees. You'll note this is a new step 3. It wasn't in our original. But as we start breaking down our ideas, we might discover, how did we get from step 2, pick up the object, to step 3, return to the start line? Well, first we've got this gap where our robot isn't facing in the right direction for driving. And while we could drive it backwards, we've designed our robot so that it can see going forwards. So we need to turn the robot around 180 degrees, and that becomes our new step 3. This kind of discovery of having a new step as we go along is not unusual. It's very important to make sure you include those steps. And the old step 3, I've kind of broken down into 2 steps. Drive forward to return to the starting line is the first step. And then once we get to the start line, we want to make sure that we stop. So we have a location for our bot to be and the object to be. Finally, we didn't have a step for dropping the object off. We want to do that now. And we indicate that through open the claw to release the object. And we might talk about the different motors we have along the way. So when we drive the robot forward, we're talking about moving motors 0 and 1. And when we drop the object, we're talking about moving motor 2. So how do we go one step further and get a little pseudocode? We really want to be discussing in our pseudocode what these things break down into, so that we're including as many details that relate to programming and to our bot. So here we're going to break down even further step 1 that we came up with. And what we said for step 1 was drive forward until the bump sensor is activated. I've reworded it a little, but that was the general premise. And what does that really break down into? This is our pseudocode. 1A, start both motors, motor 0 and motor 1, going forward. That will translate directly into code. Step 1B, ensure the claw is already open by setting it. So this is something that we're going to do with motor 2. And we can say open or set motor 2 to a specific position within our code. And here in our pseudocode, we've started to make sure that that's going to happen. 1C, have bump sensor send a message to motors if it is bumped. Now this is about coding again. It's not just enough to say have a bump sensor. We need to determine what the bump sensor is doing. So our code is going to have a reaction for the bump sensor and a message that the motors need to do something. And step 1D is, if the bump sensor is bumped, then stop the motors. Now what's unique about these is that 1A and 1B kind of like are these one-step, one-time actions. Start the motors. Once we start them, they keep going. 1B, ensure claw is already open. Once we do that, it's done. 1C is an ongoing. The ongoing is that we want to have this, while the motors are moving forward and while the claw is open, continue testing and making sure that the bump sensor is ready, so that if it gets bumped at any time during its movement, then we get 1D, stop the motors. And that would be an indication we've reached our object. Now we're stopped, then we can move on to our step 2. For the purpose of this demonstration, I've only taken step 1 and really broken it down into the pseudocode. What does this look like in code? Well, let's just take a look at 1A so that you can get a sense of how quickly this turns into code. We have our main function that we must have for every robot program. And all we need to do is turn on motor 0 at 100% and motor 1 at 100%. Now the ... would be a representation of 1B, 1C, 1D, etc. And this is how we can get from, here's our general premise, where we've identified the problem, then we create a plan, break down the plan into steps, break down each step into pseudocode, and eventually turn each pseudocode portion into real code. Thank you for joining me on how to turn your task into code.